Hi, my name is Zohar. I'm with Kaltura, and this talk is about how Kaltura is basically a platform that packages up a lot of different open source components and a lot of different practices, um, and some new components that we've introduced ourselves in order to simplify and unify. In order to simplify and unify. Uh, and provide a cohesive single platform to answer video requirements for any type of video application. We'll basically do a quick what is Kaltura, and then we'll talk about the architecture, and hopefully do some demos and discussions. So the premise of why we started Kaltura at all is because online video and video in general is actually very complex. There's a lot of different requirements, there's a lot of different solutions, and it's very, very hard to scale. So even the very simple use case of just taking an FFmpeg and running it through 100,000 videos becomes a problem. And so how do you do it at scale? How do you do it reliably? And then how do you handle all the other stuff that is required in distribution and so on? So Kaltura was basically built to provide a platform to answer all those needs. And basically our approach was there needs to be a single server solution. So one backend that is basically exposed through APIs, and then based on those APIs, applications for different industries and different practices will build customized solutions. So everything is always exposed through the same REST API. And we'll see more about this in a sec. I don't know why it shows the mailboxes here, but those are supposed to be arrows. So streaming video workflows, right? So again, going back to the mission statement, right? It's all about solving the scale problem with video. If you just have 2 videos or 3 videos, or if you want to do a home library, there are enough solutions out there. What Kaltura was set to solve is how do I do it at scale in a situation where, for example, if I'm a large broadcaster and I have a lot of VOD assets and a lot of live channels, and I need to coordinate and manage all of them and create end user applications and collect the end user statistics, distribute video to all sorts of websites and so on, and do it all and manage it all in a sane way, then you basically end up doing a lot of different workflows. So how do you manage those workflows? And that's basically what we set out to do. In terms of what are the design guidelines of the platform? Open source, it's all AGPL version 3. It's as a design guideline, the focus was around how do we solve problems that are scale problems. So again, not like the 2-3 videos or a home library, but 10,000 videos or a distribution for a university or a distribution for an enterprise with thousands of employees. Generic, versatile, or in other words, basically become the Swiss knife for video applications. So one backend with a unified API that allows you to create applications that are cross-industry, cross-use cases, without having to worry about the underlying, how do I manage FFmpeg? How do I work with this storage? How do I work with that distribution API? So again, APIs first, and then cross-industry. So ever since the beginning, we actually focused on trying to solve multiple solutions at the same time. So we actually started off with education and media, then we expanded into enterprise and doing some more things around others and real-time today. But the idea was basically, at the core premise of Kaltura was basically the idea that, yes, video is complex, but even though the use cases and practices of how do you take a video and experience it within the end user context would be different in terms of the experience, the backend of handling the video is actually the same. And so how do we work with enough industries and enough end user types and converge those practices and use cases into one unified platform? And the last thing was actually release frequently. So we actually Kaltura is being released on a bi-weekly basis, so basically every other Sunday there is a new release up. And this is rather new, but as we go more and more into live applications, how do we become more real-time and support problems like real-time analysis of video and being able to collaborate between multiple cameras, for example, so use cases like that. So in terms of the platform architecture, the core, which are basically the servers, so think about things that, for example, running FFmpeg or the database and things like that, those are basically in the core. Everything is then wrapped through a unified REST-based API. We have an automatic client libraries generator that basically runs automatically every time there's a new feature added or something like that. And those generate client libraries in many different programming languages. So if you're writing an application, you can use a native application to your programming environment, but it's always kept up to date. Then on top of that, we have all sorts of widgets. You've seen earlier today the video player. There's uploaders and recorders. And then we've built applications on top of them, and there are many different applications, both from the community as well as our own. What's interesting is that the API approach is actually the same in the backend as it is in the front end. So just like applications are using the API to make calls to the server, for example, to access database records and things like that, the backend applications are doing the same. So backend applications like batches, which are asynchronous systems that are running things like FFmpeg or email, are using the same API to actually access the database. There's no coupling between any component within the system, which basically allows for infinite scaling and very agile scalability. So what are the platform nodes? Basically, if we go back to the slide for the architecture, right? So what are the servers that are running in the cluster? We have a load balancer, obviously. The front machines are the machines that are basically handling the API layer and serving the applications, so players and things like that. Batches are asynchronous systems that are basically running things like transcoding or notifications or email sending. Sphinx, which is a full text search indexing server, an open source component. DWH, which is the analytics environment. It's basically used for log processing and database for both VOD and live. And we're using multiple components here. MySQL, or what's the new that was replaced? Or MariaDB. Master and slave, obviously, and then the NFS to handle storage. And then we also have solutions for supporting other use cases. There's an interesting Nginx model that we recently released, and the media server, which does more real-time and live. So other open source projects we're using, you've heard a lot about media info today. FFmpeg, Mancoder, MP4 box, SOX, and actually a variety of also commercial encoders. So we have integrations with all of them, and Kaltura is basically has a layer in top of inside of the batch manager. There's basically the Kaltura decision layer, and we're basically managing those transcoders in a way that, based on the information retrieved from media info, we know which encoder is better to use for what format and export, and how to improve the output of each. And there's also kind of a waterfall fallback between them. ImageMagick to manipulate images. A nice anecdote about this: thumbnails in Kaltura are done in real time. So, for example, if I need to get a specific frame from a video file, instead of having to pre-process the entire video file and then access only frames that I have indexed, Kaltura will actually, on real time, will go into your source file and generate a thumbnail for you. And then you could also, in real time, do all sorts of manipulation, like trim the thumbnail or make it resize it and things like that. And obviously it's all cached, both on the CDN as well as the server. Nginx and the Nginx model. So you've heard a lot about different problems, like how do I take a video and chunk it and serve it as HLS, or how do I do HDS, or how do I do Dash, how do I do it in real time, how do I work with those formats and serve it correctly with every other for every other system. So this can become a big headache. We recently Nginx we found is very efficient in that, but it lacked a solution that actually knows how to do those things, how to repackage, and how to create those things. So we basically created and recently released the Nginx model. There's a link at the end of the presentation which you can find. Red 5 or any alternatives like Wowza is for live broadcast and webcam recording. The Kaltura Pro library, which we talked about. And then all sorts of libraries that we use. Kaltura is mostly PHP based on the server side. There's a bunch of other programming languages, but PHP is the core. MySQL or MariaDB and Sphinx, Monit, and then for the DWH, like I mentioned before, we use a couple of solutions, Pentaho, Cassandra, and Sparks. Some notable references before we jump into a demo. If you want to, so essentially, if you want to get started and try out Kaltura, to install it, there's a link over here. We provide RPM and deb packages. Deb will soon be stable, I guess. Using Chef, we also have recipes for Chef, and there's a live community. You can get support on the forums or on GitHub. There's a knowledge center with tons of documentation. If you want to see the nightly builds or bi-weekly builds, status reports from the CI are there. And if you want to play with the fun libraries over here, you can do here. Another interesting design guideline while you set up is
I'm all set.
you can start switching. But another interesting design guideline is whenever we work on another open source project like the Nginx Model, for example, we actually try to build it in a way that is reusable outside of Kaltura too. So it will be not just valuable for the community, the other community, like with Nginx to the Nginx community, but also because it makes maintainability much easier with a platform that is so big in terms of the different components that it leverages and the different solutions that it involves. You need to find a way to segment things and make them easier to maintain by people who are outside of the platform community. So for example, the player library was actually built in collaboration over the years with Mozilla and Google, and it's actually the player that runs inside Wikipedia. And so a lot of our different components, if you go into GitHub/Kaltura, you'll see all sorts of projects there, and they all basically form the platform, but each project may actually be used on its own as well. Right, so this is Jess.
Hi everyone, so I'm Jess. Thank you for joining us on this lovely sunny afternoon. I'll be showing as much as the product as possible while we have time. So as Zora mentioned before, transcoding video is complex, and I think this screen shows part of that complexity, because if you look at it, then this is the source entry that we got, and we need to transcode it to various flavors, and each of those are different parameters to FFmpeg or whatever transcoder we're using. So it's a pretty complex process. You can see here the warnings that we're getting per flavor. The reason why we need flavors, of course, is that we have various devices, so we optimize per device. The playback on iPad will not be the same as on my laptop or on a tablet or on an Android and so forth. So we utilize FFmpeg and the other free-party software that we're using in order to optimize the source video as best as possible per source to the end device. So what I'm showing here is basically what needs to get done for that to happen. That's a big portion of our core product. As far as, we have 10 minutes, good. As far as demoing, so let's talk a little bit about the Nginx model that we've just introduced. What it does is it's able to create on the fly manifests for Dash and HDS and various other formats so that they can be played. It's not directly tied to our platform, so it can be used independently. And there's an RPM package that you can install outside our platform. And of course, you can integrate it with Kaltura's platform, which is, of course, the optimal solution. Because, we're the best and stuff. So let's take a little entry here. This one's become quite famous. Everyone uses it to demo. It's that bunny movie. I'm a bit scared of it myself, but I'll manage. So this is currently playing HDS. And you know what? Let's put it on full screen so that'll be, I guess, nicer. Alright. Okay, so no, not this. Sorry. So just to explain the integration with Nginx, basically what we do is we have our server where the entry is saved, or else it's saved on a CDN, probably a CDN. And what our player does is ask for a manifest. A manifest is just basically usually an XML, but it can be of other formats depending on the protocol you're using. And let me show it to you on the back end where things are simpler, at least for me. Yeah, let's view this. So currently I'm just making a call using CRL, which I guess everyone's familiar with, to a specific asset that we have. Kaltura's API is entirely RESTful, so you can see that the service name we're asking for here is play manifest, which is exactly what the player would do. Our player would say, okay, let's go to the server, what's my play manifest? And then it'll know where to play from. So let's just take a look at this. All right, so we can see here that it's an XML, as I said, and it's got a lot of metadata in it, and it's got the URL for the media. And what you can see here, as I said, there's one entry but a lot of flavor IDs, right, per device, optimized per device. So you can see here that this is my entry ID, like so. Yeah, I should have brought a mouse. And all these are sub-flavors of it, so they can be optimized per device. So potentially, if I'm watching it on my laptop, I'll get this. You might get this on your iPad, and someone else will get some other flavor. And of course, it's very flexible, so you can adjust the flavors created as per your needs. So for instance, an organization might say, well, I don't use iPads at all. All my employees are within my LAN, and they're all watching it on their desktops. No point for me to waste time producing these other flavors, so we can produce just the one. Someone else may say, I have very, very special needs for a very specific device, and I have my own transcoding expert. I just need you to give me the platform. I'll give the parameters myself. Fine, you can create, using our API or using GUI, you can create your own customized flavor if you know what you're doing. So that's basically the idea of it. We can see that the same entry, if I take this URL here that I've done in CRL, and I'll just put it on this Dash player here that I happen to have here. Wait a minute. And I'll just do like so. And so it plays from an external player, right, from a JavaScript Dash player. So you can see that it's the same exact URL. And what happens is that this will go to Kaltura's server. And for that particular profile, you'll say, okay, just a second. What profile are we asking? We're asking for MPEG Dash. That's good. Let's see how we handle that specific serving profile. And then we'll go on to our database. It'll say, okay, for that, we need to go to Nginx. Nginx is the one that knows how to serve this particular format. And then there'll be a relay call to Nginx, who'd actually be the one playing it. So this is the model that we have. This is what we based on Nginx. It's, of course, open sourced. It's made by a very bright man called Aran Kornblau, one of our own. And you're most welcome to look at it. I have 5 minutes. Just so you know, I want everyone to know how much time we have. I don't want to, you know.
It's also important to mention that the flavors is also for dynamic bitrate switching, so adaptive bitrate and all that.
Yeah, that's quite correct. Another note that I wanted to mention while I was looking at this presentation here is that you love effects, don't you?
No, it's automatic.
Okay. As far as these nodes, I just want to clarify that our architecture allows you to segmentize your cluster any way you want it. So this is just a suggestion on how you should segment it. But you could have them all on one server. Of course, it wouldn't be redundant, but for development purposes, that's fine. You could decide that your Sphinx runs on the same machine as your analytics, or whatever other combination you're comfortable with. So this is a mere suggestion. It makes sense to do it that way, but it's not a must. So I wanted to touch on that briefly. The last thing I want to show in my minute and a half that's left, I guess, is that, as Zora mentioned, we have client libraries bindings for a lot of languages. Let me just move to our CI system for a second. So our CI system actually has two parts. It does some local tests on a cluster, much like the one on the presentation, the same spec as the one on the presentation. But it also integrates with Travis. Anyone familiar with Travis CI? I hope so. It's a good tool. If you're not, check it out. And whenever we push a new version, it auto builds push, or whenever there's a pull request, it auto builds the libraries for all these bindings. We have a few more actually. We're in the process of integrating the rest of them. We have about 10 or 11 client libraries. So whenever something fails, you can see it, and it'll also be portrayed within that CI and the repository for the thing. So for instance, if I go here to our GitHub repository, yeah, that's a good one. Okay, so you can always see the current build status from here too. As far as our tests, we utilize the API. As Zora mentioned, our entire platform kind of utilizes itself when doing stuff, because there's the API and the various components make API requests to the core. So essentially anything that we can do internally as far as our applications can be done by an external person using that API. So pretty much all of it. So that's important to note. And whenever we commit something, we run it through all the tests, just to show how a log looks like, and then I'll ask if anyone has any questions. So think about it now. Anyways, it releases a lot of testing processes, and we have a lot of these as far as bindings. Let me just open that page just so you can get a quick glance at all the icons, I guess.
And also, if we go back to the design guidelines, it's basically all meant to create an agile development environment where people are immediately can access every new release and can stay up to date. And so the CI doesn't only build the client libraries. Right after that, we'll have a deployment system that basically pushes the client libraries to different repositories like NPM and so on.
Yeah, Ruby gems and
so if you're
so
a
forth.
developer and you're building a Kaltur
Pip.
application, you can always stay up to date in the easiest way that is comfortable for you, rather than just for us as the platform makers. And that's, I think, one of the design guidelines that we care a lot about is in terms of allowing agile development and being able to rapidly evolve with the platform.
Right. So, any questions? I was that clear, was I? Nothing at all.
Well, if you guys want to check it out, come see us, or just check it out on kaltura.com or kaltura.org.
Or grab a vagrant build.
Or grab a vagrant kit build, or do an RPM, or a dev build, or whatever.
Yeah, so just one note, since nobody has questions. We're always looking for volunteers, so we're very happy to get anyone. Client libraries, we actually need someone to correct the Ruby tests. So go, volunteer.
And our GitHub repositories love pull requests.
Yes, we love pull requests. We love them so much that I made this ugly but very functional dashboard so that our guys can see what's going on and who's pulling and who's asking.
Yeah.
It's you. See? There you go, real time, guys. So yeah, we love your pull requests and your issues when they're real. And have a good one.